The next concept we're going to take a look at is formal charge. So sometimes you have two valid Lewis structures and you want to choose which one is the best. So I mentioned this when we were talking about nitric oxide. So in order to do this, we're going to calculate formal charge. So sometimes there might be more than one or even several Lewis structures that follow all of the rules. So how do we choose which one is the best? We calculate the formal charge for every atom. Formal charge is not a real charge, but a count of the electrons formally assigned to a given element compared to that element's number of valence electrons in the free atom. So the formula for calculating formal charge is number of valence electrons minus number of lone electrons plus 1/2 times bonding electrons. Okay, so here's the formal charge. Number of valence electrons minus number of lone electrons plus 1/2 bonding electrons. So in order to use the formal charge to select the preferred structure, number 1, the preferred structure is the one with formal charges of 0. Number 2, if no such structure can be drawn, or if the structure is that of a polyatomic ion, then the best structure is the one where most atoms have formal charges equal to 0 or closest to 0. And number 3, any negative formal charges should be on the atoms of the most electronegative elements. And those are going to be the ones in the upper right, so like fluorine. All right, and you can be following along with this on your handout. There is a page with formal charges. So let's do a practice with water. So we're going to draw our Lewis structure for water, and then we are going to calculate the formal charges. So remember, each hydrogen has 1 valence electron, and we have 2 total hydrogens for a total of 2 valence electrons. Oxygen has 6, so we have a total of 8 valence electrons. 2, 4, 6, 8. All right, so here is our Lewis structure of water. The hydrogens are following the duet rule, oxygen is forming the octet rule. Everybody is quite happy. So these hydrogens, you can see, are in the same kind of situation, so the formal charges of them is going to be the same. So let's calculate the formal charge of hydrogen. So I'm just writing Fc for formal charge and then putting a little h. Okay, so we want the number of valence electrons for hydrogen, which is 1, minus number of lone electrons on hydrogen, and you can see it doesn't have any. All of them are bonding, none of them are lone electrons, so that's a 0. Plus 1/2 times the number of bonding electrons. So there are 2 total bonding electrons here. 2 times 1/2 is 1, so 1 minus 1 equals 0. So each hydrogen has a formal charge of 0. Now let's take a look at the formal charge of oxygen in water. So you count up the number of valence electrons of oxygen, and that is 6. Then you want to look at the lone electrons. So these are lone electrons, and these are lone electrons. So that's 2, 4. Then we want to say plus 1/2 of the bonding. So bonding on the left and the right. So that's 2, 4 total electrons that are bonding. All right, so 1/2 times 4 is 2, plus 4 is 6. So 6 minus 6 equals 0. All right. right, so that's just a look at how we calculate formal charge, and it just so happened that water, they all had formal charges of 0. All right, now if you take a look, this example is on your handout. Let's practice and determine the most stable structure for the phosphite ion. All right, so keep that equation for formal charge right in front of you. And we are going to take a look. So here are the drawings. Of the phosphite ions. So here are the 2 drawings that you have on your handout, and we are going to calculate the formal charges for each element in each structure of the phosphite ion, and then we're going to take a look at the formal charges and see which one is the best one. Okay, so let's calculate the formal charge of the phosphorus. Over here. So here's our phosphorus. All right, so for that equation, remember the first one is the number of valence electrons, and let's take a look at phosphorus on our periodic table. Okay, so phosphorus is right here. 1, 2, 3, 4, 5 is our valence electron count. So 5 valence electrons minus lone electrons. So those are these 2 electrons right here. Plus 1/2 of the bonding electrons. So if you look at phosphorus, it has 2, 4, 6 bonding electrons. So 3 plus 2 is 5. 5 minus 5 gives us 0. So now let's take a look at our formal charge for oxygen. Now in this case, you can see all of these oxygens are the same. They have the same number of bonding electrons and the same number of lone electrons, so they are all going to have the same formal charge. So our valence electrons for oxygen is 6. The lone electrons for these oxygens is 2, 4, 6, plus 1/2 of the bonding. And so it just has 2 bonding electrons. 2 times 1/2 is 1. 1 plus 6 is 7. So 6 minus 7 is -1. So we can go ahead and label these guys. This one has 0, -1, -1, -1. So those are our different formal charges. So remember, for formal charge, we want it to be as close to 0 as possible for all elements. And if it has to be non-zero, negative, then you want it to be on those electronegative elements. All right, so now let's calculate the formal charges for structure number 2. So we're going to take a look at our phosphorus here. Phosphorus has 5 valence electrons. Then if we look at this phosphorus, it has 2 lone electrons plus 1/2 of the bonding. So 2, 4, 6, 8 bonding electrons in this case. So 8 times 1/2 is 4, plus 2 is 6. 5 minus 6 is -1. So we're going to go ahead and assign -1 for the formal charge there. Now in this case, we have 2 different oxygens. So 2 of them have single bonds, and then 1 of them has double bonds. So we're going to calculate formal charges for oxygens 1 and oxygens 2. So this guy here is 1, 1, and this guy is 2. So that first one looks just like the ones from above. So we have our 6 valence electrons minus, you can see 2, 4, 6 lone electrons, and then just those 2 bonding again. So this one has a formal charge of -1, and this other oxygen also has a formal charge of -1. Now let's take a look at the second type of oxygen that we have present here, the one with that double bond on it. So oxygen has 6 valence electrons, and the lone electrons for this oxygen is 2, 4. Plus 1/2 of the bonding, which is 2, 4. 4 times 1/2 is 2, plus 4 is 6. 6 minus 6 equals 0. All right, so now from these formal charges, we have to decide which one is the best. Structure 1 is going to be more reasonable because it has negative charge on the more electronegative element oxygen instead of phosphorus. So if we take a look here, electronegativity basically follows the same trend as ionization energy. So it's increasing as we go up this direction. So if you have oxygen here and phosphorus here, then that means oxygen is more electronegative and it can handle more of a negative charge. So we don't want to choose the one that puts a negative charge on phosphorus. We'd rather have a negative charge on oxygen. So we are going to choose this one. Okay, so now I want you to go ahead and practice these formal charges. So I want you to assign the correct formal charge to the specified atom in the molecules below. So take a look at this one, and I want to say, what is the formal charge on oxygen? And keep in mind that double bonds count as 4 shared electrons. So these are our options. It's either +1, -1, or 0. So go ahead and pause the video and see if you can calculate the formal charges for these. Oxygen has 6 valence electrons. Then in this case, it has 2 lone electrons. And then 2, 4, 6 bonding electrons. So the double bond here and the single bond to the hydrogen counts as 6 bonding electrons. So 1/2 times 6 is 3, plus 2 is 5. 6 minus 5 is a +1. So oxygen here has a formal charge of +1. Now let's look at number 2. What is the formal charge on the carbon? Carbon has 4 valence electrons, minus, in this case, 2 lone electrons, plus 1/2 of the bonding electrons. So here is a single bond and here is a single bond. So 2, 4 total electrons. 1/2 times 4 is 2, plus 2 is 4. 4 minus 4 is 0. Now let's take a look at number 3. What is the formal charge on the oxygen here? Oxygen has 6 valence electrons minus 6 lone electrons here. 1, 2, 3 times 2 is 6. 2, 4, 6. Plus 1/2, right here we just have 2 bonding electrons. So 1/2 times 2 is 1, plus 6 is 7. 6 minus 7 is -1. So oxygen in this case has a -1 formal charge. All right, so now you know how to calculate formal charges, and remember that it's not a real charge, it's just a number that we calculate to determine which one has the best Lewis structure. So I want you to go ahead and practice calculating formal charges, and then once you feel pretty confident with it, you can go ahead and work out the problems for this section.